This test review will cover solving and graphing rationals. The first three examples, I will show you different ways to solve these rationals. And then on the fourth one, I will demonstrate how to identify characteristics of a graph. So for the first example, I'm going to use the least common denominator method. And what that looks like is for this one, since I have a difference of 2 squares in my first fractions denominator, I'm going to go ahead and factor that out. And when I factor that, that's going to be x minus 7 times the quantity of x plus 7. So now when I look at that and I compare it to the other two fractions denominators, I notice that one fraction has the x minus 7, but it's missing the x plus 7. And then the other one has the x plus 7, but it's missing the x minus 7. So what I want is both of them. So that's the least common denominator. And what I'm going to do with that information is I'm going to multiply each fraction that's already given. So this x minus 4 over the quantity, and I'm going to put it in factor form. I'm going to multiply both of those by my least common denominator. So on the outside, my least common denominator is x minus 7 times the quantity of x plus 7. And what I do to one side, I do to the other. So I'm going to put a set of parentheses around both of these fractions. And I notice in between the two fractions, I have a minus sign. So what I would do is I would change that to a plus sign, and then I would apply the negative to the numerator of the second fraction only. And on the right-hand side of that, I'm going to multiply that entire set of fractions by my least common denominator. This is the method I prefer, but some students don't understand the least common denominator concept, so this is not the one they like. So that's why I'm going to show you other strategies. So what I'm looking for is to try to get rid of my fractions. So in doing so, I'm comparing that least common denominator that's on the outside against the denominator that's in the fractions that I'm multiplying. If they are the same, or something in it is the same, I can go ahead and cross it out. And what's left over in the numerator, I can bring it down. So for this first fraction, I have x minus 4 that's left over in the numerator. If I go to the other side, I'll notice that I do have an x minus 7 and an x minus 7. Yes, both of those look the same. However, I'm still left with that x plus 7. So what I want to do with that is I want to multiply it times what's already shown in my numerator of that first fraction. So that's going to give me 6x plus 42. So 6 times 7. And then I want to do the same thing with the second fraction. What I notice this time is x plus 7 is the same. However, on the outside, I still have an x minus 7, which has to be multiplied times the numerator of the second fraction. So when I multiply this, I have to distribute it. And what I'm left with is negative x plus 7. So now what I want to do is I want to combine all of my x's together and all of my constants together. So on one side, I have a 6x and a negative x, and I also have a 42 and a positive 7. So I'm going to bring down the x minus 4. 6x minus x is 5x, and then 42 plus 7 is positive 49. I still have an x on one side of the equal sign and on the other side, so I need to combine them. So I'm going to subtract x on this side, excuse me, and then I'm going to subtract 49 on this side. So now my constants and my x's are canceled out on either side, and I am left with simplifying negative 4 plus negative 49, which is negative 53. And s set equal to 5x minus x, which is 4x. I still need to get x by itself by dividing both sides by that 4. And therefore, my final answer is x is equal to negative 53 over 4. I do want to verify that that's not an extraneous solution. So I'm going to go back to my numerator of my original problem, and it's best to look at it in factored form. So I know this is my least common denominator. And if I look at both, all of the fractions denominator, what I'm trying to figure out is what can I put in the place of x that will make my denominator equal 0? Whatever that is, I can't use it. It's an extraneous solution. So what would I have to put in the place of x to make that equal 0? Well, that's going to be a positive 7. It's always the opposite sign. And then what I would have to put here is a negative 7. So therefore, my extraneous solutions are what x cannot be, which are 7 and negative 7. So since my answer is not 7 or negative 7, I can keep it. So for example 2, I personally would use that same logic. I would use the least common denominator method, which is in this case 8y, and I would just multiply both sides by 8y. But for those people who don't like that method, what I'm going to do is the butterfly method, and I'm just going to bring down 1 over 8y, and I'm going to set it equal to 7 over 4y, and I'm going to change 5 to a fraction. And in order to do that, you just place it over 1. And now what I'm going to do is go ahead and do the butterfly wings. That's one wing, the other wing. And now you also have to multiply your denominators. So on the left-hand side, I'm just going to leave it as 1 over 8y. On the right-hand side, 7 times 1 is 7. All of this is going on the numerator. And then 5 times 4y is positive 20y. And now at the bottom, I have to multiply 4y times 1 is 4y. At this point, you still don't have the same denominators for your fractions. However, you have one fraction set equal to another fraction, which is a proportion. So now you can go ahead and just cross multiply. So butterfly means you're doing 3 steps. You're doing numerator, numerator, and then multiplying denominator. Cross multiplying, you are actually just taking the numerator of the first fraction times the denominator of the second fraction, setting it equal to the numerator of the second fraction and the denominator of the first fraction. So when I do that, 1 times 4y is 4y. Set it equal to 8y is going to multiply times all of this. So 8y times, I'm just going to rewrite it in standard form, 20y plus 7. And then whatever, when I distribute it, that's what it's going to look like. So that's going to be 160y squared plus 56y. Well, what I notice is I have a y on either side. So I want to put those together and set it equal to 0. So I'm going to subtract 4y on this side. And the reason I did that is because my y squared is already a positive number, so I don't want to move that over to the opposite side. So when I get rid of the 4y on the left-hand side, that becomes 0. And now I have 160y squared plus 52y. This method, with this method, you're going to have to factor. So most students don't like this method either. But this is what we're going to do. We're going to rewrite this with the GCF of 4y. And I'm going to divide each term by that 4y, which will leave me with 40y plus, and then 52 divided by 4 is 13. I'm going to set that equal to 0. And what that means is each factor has to be set equal to 0. So 4y is set equal to 0. And then you solve for y by dividing both sides by 4. And y equals 0. But if we go back to our original denominator, if we put a 0 there, that's going to make the entire denominator 0. So we can't use that one. So therefore, actually y cannot equal 0 because it's going to be an extraneous solution. Now, if we go to our other factor, 40y plus 13, and set that equal to 0, now you're subtracting 13 on both sides, and you end up with 40y is equal to negative 13. You want to divide both sides by 40, and therefore y is going to equal negative 13 over 40. And since it's not 0, we can keep this answer. So that's the answer for number 2 using the butterfly method. Example 3 is using the cross multiplication method. And this is the way I would look at it. Since I have a fraction on one side and on the other side that have the exact same denominator, I would put them on the same side. And if I did that, I have to make sure to change the sign of the one I'm moving. So I'm going to move the one on the left to the right, and I'm going to end up with 5 over x plus 3, set it equal to 3x plus 9, which is already over there, all over x squared minus x minus 12. Now, all I'm doing is moving the numerator. And again, right now it's plus 1, so I'm just going to make it minus 1. That's all I did. I just moved the numerator because they have the same denominator. So now when I combine my like terms here, I actually have an 8 there. So I'm going to rewrite this as 5 over x plus 3 equals to 3x plus 8. I'm not going to put this in factor form yet. You don't want to put it in factor form if you're going to cross multiply. You want to do that after the fact. All right, so now I am going to actually cross multiply like I did a few minutes ago. And this is not the butterfly. This is just cross multiplying. So I don't have to multiply the bottom when there's an equal sign in between. All right, so the first one is simply 5 times x squared minus x minus 12. So that's where I'm getting these answers from that I'm about to write, or these numbers from. So that's going to be 5x squared minus 5x minus 60 equals, and now I start on the other side. So some people may need to use the box method, so that's what we'll do. 3x plus 8 times the quantity of x plus 3, and this will help you organize your data. So 3x squared plus 8x plus 9x plus 24. And I'll notice horizontally or diagonally, diagonally, I can combine those. And now when I write it out, it's going to be what's in the boxes, 3x squared plus 17x plus 24. All right, so now that I no longer am dealing with fractions, I just want to combine all of my like terms. So I'm going to move everything that's on the right-hand side over to the left-hand side because the 5x squared is already positive. So I want to move everything to the positive leading coefficient. What I do to one side, I do to the other. So I'm going to subtract 3x squared on this side. I'm going to subtract 17x. And I'm going to subtract 24 because I just took the inverse of all of these numbers so that I could make it equal 0. And now once I simplify all of this, what I'm going to end up with is 2x squared minus 22x minus 84. And again, if I use this method, I'm going to have to factor. So LCD, that's the best way to go. And if you wanted to use the LCD method, you would have just factor out that denominator that was given in your original problem and compare to the other fraction and see which one has both or the most. Okay, so now here I can factor out a GCF of 2, and I'm left with x squared minus 11x minus 42. Oops, sorry about that. Minus 42, and I'm going to set that equal to 0. And I notice inside of the parentheses, I can further simplify. So if I'm guessing and checking, I know that x times x is x squared. So now I just have to figure out what times what is negative 42, but will also add to give me negative 11. You're going to want to say 6 and 7, but it's not that. So you can go to the side and just figure out factors of 42. So we have 1 times 42, 2 times 21, 3 times 14, and we already said 6 times 7. There's no way that I can add or subtract and get 11 from either of these. So this is the only one. If I manipulate the signs, I could actually get a negative 11 by making this a negative 14, and this is a positive 3. So what I just said, I'm going to put that inside of my parentheses. And all of this is set equal to 0. So what that is saying is each one of these factors have to be set equal to 0. So I'm asking myself, what can I put in the place of x that will make this equal 0? Well, there's nothing that will make 2 equal 0, so that's not even a factor in this case. It's a factor, but it's not something we would consider. And in the set of the first parentheses, if we put a 14 there, that would make it equal this 0, which is what we're trying to do. And if we put a -3 here, that would make that equal 0. But again, if we go back to our original denominator, we can't have a -3, or that's going to make the denominator equal 0, and we can't have that. That's an extraneous solution. So that's why you also want to know over here what this factor, the LCD is, so you'll know what you cannot use. So we can't have x plus 3, nor can we have, let me see, this would be x minus 4. So we could not have a +4 or a -3, because that will cause our denominator to be 0, which is undefined. We can't have those. Those are extraneous solutions. So x cannot be -3, and it can be 14. And it can also not be, what did I say, +4? Yeah, +4. All right, so that was all of the solutions. So now we're going to move on to graphing. So this is my problem that I'm given, and I'm going to identify the wholes, the asymptotes, the intercepts, end behavior, domain, and range. What I would do is put everything in factored form. It's just easier for me to work that way. So again, if I am still struggling with factoring, just do guess and check for now. So what's going to give me x squared? X times x. Well, what are factors that will multiply to give me +2, but add to give me 3? Well, that one's pretty easy. That's going to be a +2 and a +1. All right, so now I go to the bottom and I notice I have a negative leading coefficient, and I also can divide each of these by 2. So I'm going to take out -2, and when I do that, I'm left with x squared. This sign will change, +6x, and this sign will change also, +8. Now, what I want to do is further factor, because I can. If I look inside of the parentheses, I can further factor, and that's going to give me, let's go back here, -2 times the quantity of, well, x times x is x squared. What times what is 8, but we'll add to give me 6. Again, that one's pretty easy. +2 + 4. All right, so for our first characteristic of the graph, we see something called a hole. Well, a hole is when you have factors on the top in the numerator and the denominator that look the same. So we want to get rid of that. That's x plus 2 and x plus 2. Well, the hole is going to be a coordinate. So what I'm going to do is set that x plus 2 equal to 0, or really just ask yourself, what can I put in the place of x there that will make this equal 0? And again, it's the opposite sign, so it will be -2 for my x value. So my y value is determined based off of me taking that x that I just came up with and substituting it in for what's left over. So let's go over to the side here. What's left over is the x plus 1. So I'm going to replace that x with -2. So this is going to be my y value. Plus 1 all over -2, which is on the outside. And then what's left over is x plus 4. So I'm going to replace that x with -2 plus 4. And now I'm just going to simplify. When I simplify, -2 plus 1 is -1. And then I have -2. And inside the parentheses, I can combine that. -2 plus 4 is +2. And this just means to multiply. So -2 times 2 is -4. Well, negative and negative divide out. So that's just going to be a +1/4, which is the same as 0.25. I personally like to leave my fractions as change my fraction to a decimal when I'm graphing. So that's going to be 0.25 for the whole. And this is going to be important when it's time to graph it. You want both coordinates, x and y. All right, now my vertical asymptote, that is going to be found by looking at what's left over in my denominator. Do not include the whole. And again, you're doing the same thing. What can I put in the place of x that will make it equal 0? Now, my vertical asymptote is identified by x. So we're going to say x is equal to, in this case, -4, because that will make it equal 0. How do you remember between vertical and horizontal? To me, if I think up and down and I think the order of the alphabet, H is going to be horizontal asymptote, and then V comes after H. That's going to be your vertical asymptote. So you're working with the bottom when you're trying to identify your vertical asymptote, which goes with X, backs, and then you're working with the numerator or the top when you're talking about the horizontal, and that one spells hay, H-A-Y, because it's going to be identified by Y equals. So let's go ahead and identify that one. So I gave you in another video the rules for identifying your horizontal asymptote. What you're looking at is the degree, your highest degree. And in this case, since they're exactly the same, then the rule tells us to look at the leading coefficients in front of them. So I have a 1 over -2, which translates as -1/2. And again, for me, I like to change that -1/2 into a fraction. I'm sorry, a decimal. So that's approximately, well, it's not approximately, it's equal to -0.5. So that's the one that I will go with. It's not wrong if you put -1/2. It's just my preference. All right, so slant asymptote. Well, if you have a horizontal asymptote, like I told you in another video, you cannot have a slant one. So we will just say none. Your x-intercept is going to be identified by your what's left over in the numerator. So if I go back and I just look at, don't include what's been scratched out. So whatever's left over in the numerator, if I were to actually try to identify this x there, that's going to give me my x-intercept. So that is simply going to be -1. And my x-intercept, again, I want to write it as a coordinate. Oops, let me go back here. And that's going to be -1, 0. So your x-intercept, your y always has to be 0. Y-intercept, your x has to be 0. And the way that you want to find that is you want to actually go back to your original problem. And every time that you see, let me make some space over here. Get rid of that. For the original problem, every time that you see an x, you want to replace it with a 0. So 0 squared plus 3, 0 plus 2. What's going to happen is that's going to go away. And you're just left with 2. And on the bottom, same thing. I want to replace every x with a 0 because that's what y-intercept means. You're going to have a 0 in the place of the x. And again, that part goes away. And what's left over is -2 over 16, which can simplify as -1 over 8. And that's going to be, as a decimal, 0.125. I'm sorry, in this case, it's a negative. It's going to be -0.125. And so I'm going to write that as a coordinate. And again, this is going to be helpful when you're trying to graph, if you write it as a decimal. So you can kind of figure out where it's supposed to go. 0.125. Now, for my domain, I told you this in another video. Domain are your x values. So I'm going to look at everything that is identified as x. So this is an x, and this is an x. So my domain is going to be all real numbers except those, because those are restricted areas. So the way I would write it is, well, we'll leave it as purple, and so that when I do my range, we'll use a different color. So it's going to be all real numbers, which is identified with like that double. Okay, let me try that again. So it looks like this. That's another way of saying all real numbers except those two numbers that I just put a square or a rectangle around, -2 and -4. Those are the two areas that you can't, let's put it in order also. So from left to right, it's going to be -4, -2. As a side note, if you wanted to write this as, I'll just put it down here. In interval notation, you always start with negative infinity. You can go as far as -4. And then you can do a union and go again, pick up from -4. And then you have to stop at the next number that we said was restricted. Union, and then you can go again from -2 all the way to positive infinity. So you'll notice that you always start with negative infinity and you always stop with positive infinity. So for my range, I want to go back and let's use a different color this time. And I want to look at my restricted y values. So I'm using green this time. And everything that's green is restricted. And you notice it's associated with y. So that one is going to be all real numbers except, and then again, you want to go from left to right, -0.5 and 0.25. So those are the two areas that my range cannot include. So if I wanted to write it in interval notation, I again start with negative infinity, -0.5 union, that same -0.5 to 0.25 union, and then that 0.25, and it ends with positive infinity. That's my domain and my range. My end behavior is associated with my horizontal asymptote because my graph will only go as far as that horizontal asymptote. So if I have a horizontal asymptote, I can just automatically put the y value, because f of x means y. I can just go ahead and fill in the blank with that. So in this case, this is my end behavior. As x approaches negative infinity, f of x approaches -0.5. And as x approaches positive infinity, f of x approaches -0.5. So what you want to do is just verify on a calculator. So I already, for the sake of time, put this information in my y equals, and I put it in parentheses and then divided by using the little slash there. And if I go to graph, it's going to show me what it looks like. I'll notice I can plot some of the points based off of what I just wrote, but I just want to verify to make sure I'm on the right track, what it's going to look like. And also, just back to this, it does not show your holes or your asymptotes, but if I look, I can kind of see that it's flattening out at that -0.5 for both sides of my graph. And then for my vertical, it kind of goes straight as well here at -4, where x is -4. So let's go ahead and plot what we can based off of what I've already written. And let's see if I can, we'll use, yeah, that orange. For the whole, I'm supposed to go over -2 and then up 0.025. So somewhere in here, and a whole looks like that. All right, so that's what it's going to look like on the graph. My vertical asymptote is going to be where x is -4, and this is not going to be a pretty graph. I'm trying to freehand it, so bear with me. So where x is -4, vertical means up and down. So I have a vertical asymptote. Now horizontally means left and right, and it's saying where y is -0.5. So that's going to be somewhere down here. This is the y-axis and negative 0.5. So somewhere around here. My asymptotes are identified by a dashed line. So it's either going left and right or it's going up and down vertically. So far I have my whole, my vertical asymptote, my horizontal asymptote. Now let's do our x-intercept, which is -1 and 0. So on the x-axis, it's -1, and then it doesn't go up or down. My y-intercept is where x is 0, and then y is -0.125. So it's like right there. It just depends how you did your asymptote. And now I can try to connect my graph as best as I can. And I'm trying not to touch the asymptote. I'm just getting close to it. And like I said, it's not going to be pretty. Okay, what's going on? It's not letting me undo it. Okay, there we go. So I'm going to try to get close to it. And then I know I can't go through this hole. And then I'm going to try to get close to this one as well. So that's one side of my graph. And that's all the information I have based off of what I've written. So this is where the calculator comes in handy, because I want something in front of the -4. So more like -5, -6 type area. So what I can do is go to my table by pressing second graph. And I want to go above where my errors are, because my errors identify my holes or my asymptotes. So I want to go above it, in front of it. So at -5 and -2, I have a point. So I can go ahead and go to -5 and -2 and put a point. And then also, if I go up some more, at -7, I can go to -1. So -7 and -1. That is enough for me to kind of look at what the graph should look like and go ahead and connect my points. So I can get really, really close to the asymptote without crossing it. And the same here, I can get really, really close. And it didn't mention anything about holes or anything, so I'm good. This is what my graph should look like, and this is the information that's attached to it. So if you need more details, I have other videos out there. Go ahead and check those out, solving rational and graphing. Otherwise, go ahead and thumbs up, like the video, and subscribe. Have an awesome one.